Everyone to my talk on monitoring and maintaining large fleets of UAVs using advanced cloud and deep learning based analytics of flight logs. So I guess I've already been introduced, but just to mention again, so I'm working as a senior data scientist for Auterion, and as has been mentioned, I have a PhD in neuroinformatics. And I've been, before I joined Auterion, I was at Disney Research where I worked on using deep learning for audio generation. I'd like to start my presentation with a short video from our obstacle avoidance team. Yeah, so here you can see a drone flying fully autonomous, avoiding some obstacles in its flight path. So you can plan a mission around obstacles, and the drone will try to fly that mission, but of course avoid going into obstacles. So this is actually all completely open source, so developed by Auterion for the PX4 autopilot. So I hope that shows that we at Auterion, but also kind of the whole industry, is currently moving from doing mostly manual flights, which are happening in our visual line of sight, to fully autonomous flights that go beyond visual line of sight. But this also means this requires a completely new set of tools. So while we were mostly using remote controls in the fields or ground control stations in the fields before, now we need to have the software in the drone to let it fly autonomously, but we might also need software that allows us to connect to the air traffic management, or we might need software that allows us to monitor and manage our drones remotely. And so at Auterion, besides the drone control software that I just showed you a video of, we are developing these tools that allow us to manage, monitor, and also maintain drones remotely. And today I'd like to mostly talk about the software which we call Auterion Insights. So when we developed Auterion Insights, we had several objectives. And three of the main objectives were that the software should be able to do automatic flight upload, and I'll come to that in a second. It should be able to do automatic log analysis and error detection, and it should provide useful insights and predict future errors. So why did we want automatic flight log upload? So we had already a tool that allowed users to upload the data manually and review it and also report problems. But what we saw was that users only uploaded the data when they actually had a problem, when they needed help. And while this data is very useful because it allows us to improve our flight control software, it also meant that we didn't see the full data. So we were not really able to do statistics on this data or make informed decisions what the important failure cases are. So that's why we then decided we need something that allows the drone to always be online. And so we developed it such that while the drone is flying already, the data is automatically streamed to our cloud tool and analyzed there. So just to show you some data that this actually worked, so these are the number of flights on our cloud servers per month, and this is only from our internal team here. But at the time point that we moved all the drones to do automatic data upload, so while it was manually happening before, we saw a really steep increase in the amount of data that we had on our servers. So to the second objective, why do we need automatic flight log analysis? So I already just showed you that we now have a massively amount more data, not only because of this automatic upload feature, but also because we are flying more, and also our clients are actually flying more. So manual analysis simply doesn't scale to that anymore. So you won't be able to detect all the problems by manually going through all the data. So if we are able to do automatic analysis and find errors in the data automatically, this we can actually accelerate our development cycles and therefore increase the reliability of our drones. So how do we do automated flight data analysis? So most of the data we get is actually time series data, like sensor data, for example. So what you want to do is you want to find the parts in your data that are somehow abnormal compared to the rest of the signal, or also compared to all the other signals that you see. And so what you need to do is you have to find a metric that kind of tells you it's abnormal compared to the rest. And if you calculate such a metric for parts of the signal, and for time series parts of usually means a time window, and when you do that for all parts of the signal, you can threshold your metric and actually find the parts of the signal that might be problematic. So how do we calculate such a metric? So for some signals it might be enough to calculate simple features like using a moving average or max or something similar, but for others that's not enough. So you might need to either work on more complex features from, for example, frequency analysis, or you might even use deep learning to come up with such a metric for you. So how can you use deep learning for getting a metric? So that's just an example, but one type of network that you can use actually is a so-called Auto-Encoder Network. So deep neural networks are usually trained to produce a desired output from the input that we provided. And an Auto-Encoder Network is trained to produce the same exactly same output that it receives as an input. But usually the network's somehow constrained. So by having, for example, some layer of lower dimensionality in the middle. And so that means if you train such a network on a lot of data, and when you assume that this data mostly contains kind of normal signals, that means that the network can only, or has to learn the key features of this normal data in order to do its job very good. So if you then take such a trained network and feed it with abnormal data, it will still try to produce normal data out of this, the input signal. So simply then subtracting the input from the output gives you such a metric that tells you, how normal or abnormal your signal is. So that's one way how you could use deep learning, for example, for coming up with an abnormality metric for you. So now you have the metric, but actually what you want is you want to have a kind of single number that tells you how good or bad your signal is. So you need to kind of calculate some statistic now from the metric. And there are also different ways how to do that, but you can also, in this example, just take the maximum of your metric and say, okay, that's my statistic that tells me how good or bad my signal is. And now you can look at the statistic, do this for a lot of flight data. And what you can see here is one of our vibration metrics actually. So on the y-axis and on x it's just a distribution in standard deviations. So every dot that you see here is actually one flight log. And the data that's shown here is public data from the PX4 developer community. So unfortunately, I can't show you any data from our clients because we're very diligent with this data. But so that's developer data from the PX4 community. And high value here means basically that you have high vibrations in this flight data. And what you can do now is you can threshold this data at some point. And now when a new flight log comes in, you can say, okay, if it's above the threshold, then I'll send an alert to my user and say, okay, you might have a problem here with vibrations. And that's actually one of the key features also of our software. But you can use the same data to gain some insight. So this is again the same data, just visualized a bit differently. So in color here you see the different vehicle types that are flown by the PX4 community. So the big brown blob here is all quadrotor data. There's some VTOLs in blue and pink. And so you can gain some, you can put in some different factors and then maybe find out that some types of vehicles perform differently than others. So what I should mention here maybe is, so for the ones a bit familiar with VTOL, so this is not a max vibration metric. Otherwise, for the ones a bit familiar with VTOLs might know that during the transition phase they usually have quite some vibrations. But you can even visualize your data, for example, over time. Again, the same data now. And if you want to, for example, detect some trends. So here, what this kind of tells us, or how this looks like, is that the vibration data of all these PX4 developer flights seem to have increased over time, right? So when we first saw that, we were a bit surprised. So we would have expected that it stays constant or even goes down over time. So we decided to investigate this a bit further. So what we saw here from this plot is that it seemed to have increased mostly at a single time point, actually last year. So we looked a bit further into that and plotted the same metric now only for a single vehicle. And we saw again the same. So at some time point, there was a sudden increase in our vibration metric. And what you can see here, plotted in different colors, are different versions, software versions of PX4 that the vehicle was flying. So it seems like there was one version, or like a version change, that suddenly increased this vibration value. So which is actually very helpful to find out. So what we did then is we went to our engineers and they had a look at some release notes and then so on, and had a look at what changed at around that time point, and then they said, okay, yeah, at that time point we decided we do actually less filtering on our sensor input. So they told us what you're seeing here is actually not an increase in the vibrations in the vehicles, but you get now more information about vibrations in the signal that you're analyzing. So this is very helpful, but also shows us kind of you need to really look carefully at the signals that you analyze, right? And so with this, I'd like actually to summarize, and so I showed you that fully autonomous drones require a completely new set of tools. I showed you how automatic file upload can enable informative decision making, and how we can use automatic flight data analysis to accelerate development cycles. I also showed you how we can gain insights and do predictive maintenance on population data, and I want to conclude by saying that cloud tools for flight data monitoring can boost UAV reliability. And with this, I'd like to thank you especially all for listening, and the great team at Auterion that has enabled all of this and created this nice software. And I'd like to encourage you to visit us at our booth at 2009. Thank you. And I'm open for questions.
Questions?
Hi. First of all, great work. Thank you. Can you talk a little bit about how if you are starting to account for environmental factors and things that aren't directly part of the flight controller that may impact some of this? So for example, if you're flying through abnormally bad weather or higher wind conditions for a period of time, that could impact vibration levels, it could impact a bunch of things in the airframe. If the payload changes, are you looking at ways to account for those things as part of the analysis?
Yeah, we're definitely looking at that, but that's of course a challenging problem. But so what you can do is you can come up with more complex models that don't work just on a single signal, for example, but take account different sensors, and which we actually also already do. But yeah, it's of course challenging to.
So you talk about predictive maintenance, and is it more that the drone itself will fail, or are you looking at, you need to take a look at the motors, you need to take a look at the props? Are you able to differentiate down to that level, or is it, the drone will probably fail, or there's just more vibration? I'm looking for, like, is there a distinction in the amount of specificity in your maintenance or your predictive ability?
Yeah, so yes, there definitely is. So we are almost looking more on the specific sensors and types of signals at the moment than on the whole level actually. So it's really, so we can see, so we have some of these metrics, for example, for that qualify the magnetometer quality, for example, and then so when you see this metric, increasing or decreasing depending on how you put it over time, then you get, then you see that you might have, for example, a magnetometer problem. And so that's what we can do. Not about all things that we would like to yet, as good as we, but we can definitely do that.
Questions? Any other questions? You're getting off easy.
I have more, I'll save for the booth.
Yeah, feel free to talk to me at our booth or later, just so that's also.
Right, no other questions? Let's thank Dr. Brand.